Question 21. A police jeep is chasing a culprit going on a motorbike. The motorbike crosses a turning at a speed of 72 kilometers per hour. The jeep follows it at a speed of 90 kilometers per hour, crossing the turning 10 seconds later than the bike. Assuming that they travel at constant speeds, how far from the turning will the jeep catch up with the bike? Solution. Velocity of the police jeep equals 90 kilometers per hour equals 25 meters per second. Velocity of the motorbike equals 72 kilometers per hour equals 20 meters per second. In 10 seconds, the culprit reaches point B from point A on motorbike. So distance covered by the culprit, say S equals versus T equals 20 times 10 equals 200 meters. It means police jeep is 200 meters behind the culprit at T equals 10s. Now, relative velocity between both. Time equals S by V equals 200 by 5 equals 40s. Police jeep will move in 40 seconds from A to cover distance S. S equals versus T equals 25 multiply 40 equals 1,000 meters or 1 kilometer away. Thus, the police jeep will catch up with the bike 1.0 kilometers away from the turning. Question 22. A car traveling at 60 kilometers per hour overtakes another car traveling at 42 kilometers per hour. Assuming each car to be 5.0 meters long, find the time taken during the overtake and the total road distance used for that overtake. Solution. Velocity of the first car, say V1 equals 60 kilometers per hour equals 16.7 meters per second. Velocity of the second car, say V2 equals 42 kilometers per hour equals 11.7 meters per second. Relative velocity between both the cars equals 16.7 minus 11.7 equals 5 meters per second. Consider S be the distance traveled by the first car W, R, T, second car while overtaking, so S equals 5 plus 5 equals 10 meters. Let T be the time taken while overtaking. T equals S by V equals 10 by 5 equals 2S. Now, distance covered by first car in 2 seconds is D equals V1 multiply T equals 16.7 multiply 2 equals 33.4 meters. Also, car covered its own length, i.e. 5 meters. Thus, the total road distance used for the overtake equals 33.4 meters plus 5 meters equals 38.4 meters. Question 23. A ball is projected vertically upward with a speed of 50 meters per second. Find A, the maximum height, B, the time to reach the maximum height, C, the speed at half the maximum height. Take G equals 10 meters per square second. Solution. Initial velocity equals U equals 50 meters per second. Also given, G equals A equals minus 10 meters per square second. A, at highest point velocity, V equals 0. Using relation, S equals V squared minus U squared by 2A equals 125 meters. Maximum height equals 125 meters. B, let T be the time taken to reach at maximum height. T equals V minus U by A equals 0 minus 50 by minus 10 equals 5 seconds. C, half the maximum height equals 125 by 2 equals 62.5 meters. Using relation, S equals V squared minus U squared by 2A. V equals square root 2AS plus U squared equals square root 2 multiply minus 10 multiply 62.5 plus 50 squared equals 35 meters per second. Question 24. A ball is dropped from a balloon going up at a speed of 7 meters per second. If the balloon was at a height 60 meters at the time of dropping the ball, how long will the ball take in reaching the ground? Solution. Height of the balloon equals s equals 60 meters. Velocity of the balloon moving upwards equals 7 meters per second. When the ball is dropped, its initial velocity, say u equals minus 7 meters per second. Acceleration due to gravity, a equals g equals 9.8 meters per square second. Using equation, s equals ut plus half at squared. 60 equals minus 7t plus 1/2 into 9.8 into t squared equals 4.9t squared minus 7t minus 60 equals 0. Or 49t squared minus 70t minus 600 equals 0. Solving above quadratic equation, we get equals 7t plus 20 into 7t minus 30 equals 0. Either 7t plus 20 equals 0 or 7t minus 30 equals 0. T equals minus 20 by 7 or t equals 30 by 7. Time cannot be negative, so neglect negative value. Therefore, ball will take 4.3 seconds to reach on the ground. Question 25. A stone is thrown vertically upward with a speed of 28 meters per second. A. Find the maximum height reached by the stone. B. Find its velocity 1 second before it reaches the maximum height. C. Does the answer of part B change if the initial speed is more than 28 meters per second, such as 40 meters per second or 80 meters per second? Solution. A stone is thrown vertically upward with a speed of 28 meters per second. U equals 28 meters per second. Final velocity equals V equals 0 when stone reaches the ground. Also, acceleration due to gravity equals A equals G equals 9.8 meters per square second. A. We know V squared minus U squared equals 2AS, or S equals 40 meters. The maximum height reached by the stone is 40 meters. B. Using relation, V equals U plus AT, or T equals V minus U by A, or T equals 2.85 s. As per the question, we need to find the velocity of the stone 1 second before it reaches the maximum height. T dash equals 2.85 minus 1 equals 1.85 s. Again, V dash equals U plus AT dash equals 28 minus 9.8 multiply 1.85 equals 9.87 meters per second. The required velocity is 9.87 meters per second. C. No. Reason. After 1 second, the velocity becomes 0 for any initial velocity and acceleration, A equals minus 9.8 meters per square second, remains the same.